So the question asks, 500 units of good X are currently bought and sold. The marginal buyer is willing to pay $40 for the 500th unit, and the cost to the marginal seller is $35 for the 500th unit. We know that, and we have our choices here. So to begin this question, it's best to draw the supply and demand curve. So we will create the supply and demand curve. On the y-axis will be the price, and on the x-axis will be good X. So the 500th unit is somewhere here, it's just an arbitrary point on the graph here. We'll just call that the 500th unit because of course this is the quantity as well. So when we're looking at the price here, we know that the demand, because demand is related to the buyers, is going to be higher up. So 40, it'll be some arbitrary point on the y-axis. So let's just say right here, this is 40. And what we'll do, we'll draw all the way out until we reach this point right here. And we'll do the same thing with the 35th unit. So it's, again, some arbitrary point, but we'll just say 35 right there. And we'll draw all the way to the 500th unit right there. So what I've done here is essentially I've marked where my demand and my supply curves are going to be at. So now I've fully made my supply and demand curves. And as we can see here at the 500th unit, these are the points right here. So we can definitely tell that demand is greater than supply. So let's go through the answer choices. A, the equilibrium price of good X is somewhere between $35 and $40. That is correct because these prices are different. If they are the same, we know that it'll be at equilibrium, but it's not going to be above $40, as you can see right here. Even though this is a rough estimation, we could easily see that it's in between $40 and $35. The equilibrium quantity of good X exceeds 500 units. This is also true. And again, even though this graph is not drawn to scale, you can obviously see that it's going to lie beyond 500 units. You know, we could just estimate and we'll say 600 just as an estimation. And lastly, C, 500 units is not an efficient quantity of good X. This is also true because to be efficient, you want to be at the equilibrium point. Therefore, we're not at an efficient point in our model right here. So the correct answer is D, all of the above.